finally geological engineering student. My whole project was about studying the mechanical properties of Sisal reinforced fibers. Sisal reinforced PET. PET, these are the plastic bottles, which are right here. The plastic bottles. These plastic bottles, when combined with Sisal, could be used in 3D printing housing, could be used as a construction material. So, why this project? Due to increase in the prices for cement, the modern houses or traditional houses, they are not durable, and they have so many challenges like cracks. During the time of disasters, they can easily collapse. So, and another problem is environmental management. I mean, it also, the project is trying to address the environmental challenges, like plastic waste disposal. So, instead of throwing the plastic anywhere, how about we come up with these plastics? How about we try to repurpose these plastics into a construction material, which is that could try to reduce these challenges. So what I actually did, the first thing was to melt the plastics and combine them with Sisal, and in different ratios. So first of all, I had to select 5% Sisal, 10%, 15%, and 20%. Why 20%? Is because, first of all, 10%. I'm trying to come up with I'm trying to select the best mix design that would give us the best mechanical properties of this product. So here is the flow as shown on this. I had to melt the plastics. After shredding them, I have to melt the plastics. And after melting them, I had to mix them with Sisal, which were cut into 10 to 30 millimeters. Then I had to cast them in the mold. So this is the mold that I used. Normally, the original plan was to use a standard molding, but due to the budget constraint, I had to adapt and use this rock as a mold. It is as a mold for the product. So after that, these are the final products. As you can see, they are very strong, very hard, and after coming up with these products, I had to test for mechanical strength. For example, the tested mechanical properties were uniaxial compressive strength, water absorption, and hardness test. So these tests, they are very important in determining the strength of the materials, especially the UCS, whereby you're trying to check what would the material behave under the loading. How would it behave? So that's why I try to conduct UCS. The hardness also, I also had to do it. And the water absorption, because the water reduces the strength of the material. So if the material absorbs more water, it means that the strength itself will be weakened. So that's why I had to do it. So these are the results. At least the material itself, it had like above 4 MPa for UCS, and the rope 41 as a hardness, and 0.5% for water absorption. So the results were compared to standards Malawi Bureau of Standards and as well as other literature reviews. So the challenges, like I said before, I was supposed to use the standard modes, but due to they are very expensive, they're actually expensive. So I had to adapt with the situation and come up with this metal as my product. So because of that, I had to use this one, this mode. So that's another challenge. So limited access to advanced testing equipment required for methodological adaptations. So another thing is the variability. More size of fibers, according to the results, 10% is the one that gives the best mechanical properties. So more sizes means more defects. And next size means that the best one is 10%. So what happens is, as we increase the size in this product, the materials will be weakened. But the optimal one, the best combination that balances both the mechanical strength is the 10% of Sisal. So this is it. So recommendation: as soon as I melted these plastics, there's a rapid cooling. So rapid cooling, it produces some voids within the product itself. In order to control that, if we control the rapid cooling, it might enhance its mechanical strength, because more voids shall mean lower strength. So that's I would recommend control. If we have the control of the cooling itself, we'll have the best product. And another thing is further testing of other material, because I only used Sisal and the plastics, but other testing should be also conducted. For example, cement or other materials. So that's my recommendation. So far, there is this project, or that is Total Housing Solution by Malawi Housing. They are planning to build houses which are durable but affordable, at the same time affordable. So the idea is to contract those houses. So my student is to reach out to Malawi Housing and tell them this idea. Because it is, like you see, it is also automate cement, because cement is very expensive these days. So if we use this idea, it might help to solve those challenges, like environmental challenges, which is also supports Malawi sustainability and recycling goals. Okay, I would improve in the standard testing methods. For example, I did not conduct all the tests that I wanted to, due to lack of due to unavailability of some other testing equipment. Some equipments were not available, some are not working. For example, I was supposed to conduct tensile strength. So because of the machines for testing, they are not available. So I would try to improve in such areas, and I'll conduct further tests to explore the property of the material itself, because I've only conducted 3 tests, like UCS, which is unilateral compressive strength, water absorption, and hardness.